Okay, we are going to do integration using substitution here. The problem is we're not given what exactly it is we need to pick for the substitution. So think about it this way. You know that whatever you pick for the substitution, you must take the derivative of, and it has to be present in what you're already looking at. So if you're looking at something like a power rule kind of derivative, what you want to pick is whatever is the higher degree. So looking at this one here, number 4, I can pluck out 7x squared plus 3 because that right there is bigger in power than the x at the top. And let's just see what happens. If I take u to be 7x squared plus 3, well, what happens when I take the derivative of u? Well, I get 14x dx. Well, the cool thing is that I already have an x, so that checks off of my list. So I'm going to check that off. Okay, what am I missing? I'm missing this 14 right there. So remember the famous mathematician James Tanton, he says when you want something in life, make it happen. So we're going to make it happen. We're going to write a 14 there, but deal with the consequences. The consequence of having that 14 there is that I must also have 1 out of 14 on the outside because I cannot multiply by the integral by anything other than 1. Okay, so you've got to, the other way to think about it is it's an accounting method. You have to account for everything that needs to be there. All right, and then you make it happen. All right, so accounting method, make it happen. Account for everything that you need. All right, and so now that I've done that, I have successfully picked out what it is that I need for my substitution. And so now I'm going to rewrite this a little bit. And let me go ahead and maybe write it over here off to the side. I'm going to write 1 over 14 first. And then I'm going to write my integral symbol here. I'm going to write 14x. And then I'm going to write this right here, what was in the denominator, 7x squared plus 3 to the negative 5th power. Because I want to bring it up to the top. So it makes it a little bit easier to integrate here. Now I'm going to ring everything that's associated with my substitution method. So 14x dx, that right there represents my du, and this right here represents my u. So now I'm ready to write this. I'm going to have 1 over 14 on the outside, and on the inside I'm going to have u to the minus 5 du. And now I'm ready to integrate. What do I get? I get 1 over 14, and then I have u to the negative 5 plus 1, so that's negative 4 divided by negative 4. Okay. And then what do I get? I get plus c. I get plus c. So then I end up with, let's see here, 1 out of 56 negative. So what is that? Negative 1 out of 56. Right? Negative 1 out of 56, u to the minus 4 plus c. All right? Negative 1 over 56, u to the minus 4 plus c. And so I'm ready to back substitute. And I'm going to say negative 1 out of 56. And then u to the minus 4, instead of u, I'm going to write 7x squared plus 3 to the negative 4 plus my constant of integration, c. And now I am set. Okay, I'm set. I'm ready to go. There's my answer. Okay, nothing to it. All right, the hard part was picking out u, but I've given you some solid advice. So think about the next one, number 5 here. Okay, on number 5, if you are asked to pick u, what would you pick? Okay, well, you might pick x to the 9th minus 10. It's a higher degree. Now let's take the derivative. du, what do you get? 9x to the 8th power. Well, I can account for my x to the 8th. It's right there, okay? And actually it's missing the integral symbol. I can account for the x to the 8th. What am I missing? I'm missing the 9. Okay, so I'm missing the 9. I'm going to write the 9. All right, there's my 9. That's what I'm missing. By consequence, I need to write 1 out of 9 on the outside. All right, now I'm ready to go. Okay, so my 9x to the 8th dx, and I need to write dx over here, as a matter of fact. There it is. My 9x to the 8th dx, that's my du. And this x to the 9th minus 10 is my u. And now I am ready to integrate. I've got 1 out of 9 multiplied by the integral of u to the 4th power du. All right, and then it's pretty straightforward from here, the integration. I've got 1/9 times u to the 5th over 5 plus c, can't forget the plus c. And then that equals 1 out of 45 u to the 5th power plus c. What do I end up getting? 1/45 of x to the 9th minus 10 to the 5th power plus c. And so I've completed my substitution process there. So again, reminders, pick a u probably that's a higher power, and be sure that the lower 1 power less, because that relates to the derivative, is present. All right. If it doesn't quite work out that way, then you probably have to do another method to integrate. There's a method called integration by parts that's really handy, but not discussed here. Substitution's really nice. Again, this is a way to undo the chain rule, how to take the antiderivative. Anyways, if you had a chain rule problem. So I hope this video was helpful, and as always, remember, like and subscribe.